Okay, last time we left off talking about the range, which was our first very simple version of thinking about measuring dispersion. This time I want to move on to, I want to get us to something that's a little more complex and a little bit more useful. But first, I want to think about a different level of measurement and talk about how we might measure dispersion in that case. And I think it helps illustrate what's happening with dispersion. And I want to go down to the nominal level. The nominal level is always going to be the one that produces special challenges for us because we can't line things up, we can't add and subtract. We just have stuff in categories, and so it makes things a little bit more difficult sometimes. How could we measure dispersion, the concentration of the data? How could we do that? The variability, how could we do that with nominal level data? Well, let's go back when we were doing levels of measurement. We had this example about shoes, right? So let's just suppose some data here about shoes. I'm just making this up, but let's say we went into somebody's closet and they had 12 pairs of athletic shoes and they had 23 pairs of casual shoes and they had 15 pairs of dress shoes. Okay? Great. There's our data. That's what we're going to analyze here. What can we do to represent the dispersion in this kind of data? Well, there's not much. We can just talk about how much is in each category, right? How concentrated it is in each category. And that's what we do. What we typically do with this kind of data is we look at the category that has the most, the modal category, and that defines what dispersion is in this case, okay? So there's other ways of doing it, but this is the one that we're going to focus on. Concept I'm going to use is called variation ratio. Little calculation we're going to do. And this is going to be our first formula. When we have a formula, what do we do? We just take a few deep breaths, we calm down, we don't get intimidated, and we just wait until we explain all the little different pieces of the formula and we understand it perfectly. This is a really easy one, so this one's probably not going to freak you out too much, but nevertheless, I just want you to kind of prepare yourself when we get to these formulas. Okay, so variation ratio equals something. We're going to calculate this variation ratio. How are we going to do that? Well, it's really easy. It's 1 minus the number of cases in the mode, divided by the total number of cases. You remember we used n to talk about the total number of cases, and the mode was the category that had the most in it. All right, so that's what we're going to do. That's it. That's a whole formula. Really easy. You might see something, just to keep us honest here, you might see something where you have n with a subscript or something like that. So the number in the mode divided by n. That might be how you see the variation ratio formula written out. Okay? So how do we calculate that for our data here? Well, it's really simple, isn't it? We just need 1 minus the number in the mode. Well, what's the modal category here? The biggest one is casual shoes, and we have 23 in that. So, 23 divided by the total number of cases. How many is that? Well, it turns out to be 50 if you add up those numbers. Okay? And so that equals 1 minus 0.46, which equals 0.54. Ta-da! We just use the formula to calculate the variation ratio of this data. It's very simple, very straightforward. Okay? All right. Now, the thing to appreciate in terms of how this gets us to dispersion is that as one category starts to dominate the data more and more, as things get more concentrated in one category, the variation ratio starts to approach 0. It starts to approach 0. That means there's no variation. So the smaller this number is, the less variation there is. As things get less concentrated, as they get more spread out between the different categories, the variation ratio gets closer to 1. And that means there's a lot of dispersion. There's a lot of spread of the data. There's a lot of variation. Okay? So if you just think about that for a second here, if this number is getting if this number is getting big, so the number in the mode is getting big relative to what's underneath at the n, as this is getting closer and closer to n, this part of the equation is getting closer and closer to 1. And that's making this thing, the overall thing, get closer to 0. It's very, very simple. The other side is this thing gets lower and lower, then this part of the fraction is getting closer to 0, which is making the overall thing closer to 1. Okay? That's all there is to it. It's a very simple kind of notion. All right? Let me give you a little example of that just to make it a little bit more clear. All right, so let's just remember the variation ratio equals 1 minus the number in the mode over the total number. Okay? All right. Now, I had this experience after the last election where a friend of mine got riled up, as he often does, and he put a post on his Facebook wall. He was reposting an article, and the article claimed that it had evidence of voter fraud, and that what they had discovered that made them think there was voter fraud was they discovered some precincts where 100% of the vote had been cast for Obama. 100% had been cast for Obama. And that just seemed implausible to them, and therefore there must be voter fraud. And if you think about it, it is kind of seems implausible on the face of it because, you know, maybe in an urban area, which is where these precincts were, maybe you would expect that there were more Democrats than Republicans. That would be fairly typical in a, maybe 50% of the population might be Democrats in an urban area. Maybe 30% might be Republican. Just making this up for the sake of the example. And maybe 20% are sort of independent. Okay, so they don't identify with either party. Okay, in that case, you know, it does seem unlikely that you could get 100%, every single voter voting for Obama. That does seem strange. Okay, what's the variation ratio with this kind of data? Well, the variation ratio would be 1 minus the number in the mode, which is Democrats, so 50 divided by the total would be 100. Okay, and that equals 0.5. Okay, so that's our variation ratio. Well, it turns out that actually things were a little bit more concentrated in these precincts than you would generally expect in an urban setting. Okay, it actually turned out that in those precincts, there actually 100% of the voters were Democrats, and 100%, if you look at it by race, 100% of them were African American too. Okay. Now, under those circumstances, it doesn't seem quite as crazy that everybody would have voted for Obama. What's the variation ratio in that situation? Well, the variation ratio wasn't 0.5. It actually was 1 minus the number in the modal category, which is 100, divided by the total. I'm using percentages here, but it would work out exactly the same as if we had the numbers. If there were 4,000 voters in the precinct, it'd still be 4,000 over 4,000, so it works out exactly the same. And that equals 1 minus 1, which equals 0, right? And we said, when it's completely concentrated in one category, there's no variation, and therefore the variation ratio should be 0, and that's what we came up with, okay? So there you have it. That's an example of the variation ratio in action. Okay, that's it for the nominal level of measurement and dispersion.